Hi guys, welcome back to Let's Upgrade DSA program. So I hope you all are doing good. So yesterday we saw what are the recurring functions and how can we master them. What is the difference between the loops and the recurring functions and where we can use them wisely. So today we will look forward to it and we will start with time complexity. Over to you, sir.
Yeah, thank you, Anshika, for that quick recap of whatever we have done yesterday. So, guys, we have done recursion yesterday. I'll show some examples of recursion today. Even today, we'll start with recursion, and we'll move into this time complexity. So, time complexity is again a very important topic, a very important chapter in as far as data structure and algorithm is concerned. As far as your competitive coding is concerned, everywhere you go, like you go to product based company or service based company, you go to any interview, anywhere, time complexity is a very important part of your data channel concepts. So yep, we will start with some examples recursion, and as in the flow we would enter into this time complexity. Okay, so first of all, hi everyone, good evening. I hope you all are doing well and all are safe. So let's see who all are there today in the stream. Okay, I see Aman is there. Aman is there. So Aman, hi, good evening. So many people are watching. Where are the chats, guys? Okay, let's see in the LMS who all are there. So guys, today we are like doing this in both YouTube and LMS. From tomorrow onward, we'll not do on YouTube. It would be only in LMS. So if you have not registered in LMS, if you have not in the LMS right now, please register it soon, and you can watch it from here. So let's see who all are there in elements. Yashwant is there. Pratarth. Hi, Yashwant, Pratarth. Shivendu. Aman is also there here. Venkat Raman. Uh, Sharath is there. Great. Swati is there. Divyani is there. Shankalp is there. Yashwant is there. Madhavan is there. Jyotikaran is there. Great, guys. Great. So, good evening, guys. How are you all? I hope you're doing well. Sriniket is there. Sezal is there. Venkat Raman. Okay, I have just taken the name. Shivani is there. Sanjeevani is there. Sorry. And yep, Smita is there. Vamsi Krishna is there. Aruna is there. Vipin. So, yep. Hi everyone. How are you all? Shraddha, Lakhan, Vaibhav, Sandhya, Ansar, Priya. Great. Komal is also there. Okay. That's great. Others is there. Gaurav is there. Hello everyone. Hello everyone. So let's make this colorful. Let's make this more excited. Please put out some emojis, guys. In both, if you are on YouTube, put out there. If you are in LMS, put some emojis there. Maybe you can use your last emoji, whatever emoji you have recently used. You can put out that emoji, or maybe you can put your favorite emoji out there. Let's make it colorful and let's start with a bang. So let's do it. Once you do it, then we'll start with this. Yes, now I'm seeing emoticons. Like Komal is the one who has started first, putting emoticons in the LMS. Let's see in the YouTube who had output. Okay, Prasant is there in the YouTube. Chirag, Priyanshi, Prashant, Navin, Ravan. Yep, Shaurav is there. Chirag, Shurya is there. Madhura is there. Divyendu. Great. Hi guys. Yeah. So I'm seeing now emoticons over there. Great guys. So all of those who are watching on YouTube, it's fine for today, but from tomorrow onward, we have to shift to LMS. There would be nothing in YouTube, guys. So please enroll into LMS, get into that, register for the like, get enrolled, and watch it from the LMS. Okay. Yes, as I've said today also, I'll be sharing a link to the form in order to get that 50% discount on a full stack course in data structure algorithm, which also includes your placement preparatory course, which will prepare you for both service-based company and product-based company. You'll be getting your one-to-one mentorship, projects, many things. Okay. Majorly will also do this OOPS, will also learn OOPS there. DBMS Oracle will cover some important topics of operating system over there, which they ask in interviews day in and day out. So all those stuff will be learning in one complete package, that is full stack programming, data structure, and algorithm. Okay, so yeah, so I'm not sharing that. I'll share that somewhere in the in between. So don't worry about that. Okay, fine. So now Let's start with today's discussion. As I said, we'll start with some example of recursion. Okay, so I've already kept this whiteboard and all open, so I'll directly share that screen and I'll go towards it. I hope now all of you have a clear idea how to go to like LMS. I've already told you all in the last session, in the previous session, how to get enrolled in LMS, how to watch the video there. So I hope we don't want to have a repeat. I don't want to waste your time. So let's start discussing this recursion a bit more. Okay, so let's do one question. That is, I want to print 5 4 3 2 1. So I want to print here this numbers, natural numbers, or maybe n minus 1, so on. Okay, I want to print n natural numbers in reverse order. So the same question, and let's say n value is 5, so I want to print 5 4 3 2 1. Same question, if I go for an iterative method, so this would be like for I equal to 0, for I equal to not 0, I equal to 5. Okay, I less than equal to, not less than, again it should be greater than equal to. Okay, so I greater than equal to 1, I minus minus, right? Okay, so yeah, I minus minus, and we would here print the value of I. So I'll get here, first I value is 5, so I'll get 5, then I value would be 4, so I'll get 4, then 3, then 2, then 1, and finally I would become 0, so the condition will be false and I'll come out of the loop. Okay, this is how we do in iteration. Same thing if we go for recursion. So I said every iteration can be converted into recursion. So how to do this question in recursion? So take the value n is 5. Okay, so what we need to do, let's say I will go for a function here, void, same function, let's say print. Okay, and it is taking this argument n whose value is 5 right now. Okay, so what we want to do here, n is 5, n is 5 here. So basically, first of all, we would print the value of n, that is 5, and then we'll call the function with n minus 1. That is what we need to do. But one thing we have forgotten, that is, I said that there should be a stopping condition. Like in a loop, in an iteration, there is a stopping condition. That is, here you have mentioned I should be greater than equal to 1. So if I becomes 0, like if it is less than 1, or we can say if it becomes 0, then we'll stop it. Okay, I'll definitely code it around. Let me first explain how it works, and I'll code it around. Okay, don't worry, I'll code it. So like in the iteration, we have a termination condition. Even here in recursion, we need to have a termination condition, because if you don't have a condition, then we'll end up into, what do we say, in iteration we'll get we'll end up into infinite iteration or infinite loop. Similarly, in recursion, if we don't have the termination condition, we'll enter into an infinite recursion, and we don't want that. What would happen, guys, when if you enter into an infinite recursion, then what would happen? Yeah, Chirag, I'm saying that. I'm doing that. I'm explaining it again. So this is the for loop for this thing. We understand this for loop, how for loop works. For the same thing, we would write a recursive logic for the same. So the my point is, if we don't have the termination condition, there should be some condition where the recursion should stop. If we don't have that condition, we'll obviously end up into infinite recursion. So what would happen if we end up into infinite recursion? Attendance form is unavailable. Just give us a moment. Just give us a moment. It would be done. Okay. Yeah, Kirtana, can you have a look on that? They are saying, like our students are saying the attendance is not working. Please, can you have a look on it? Yeah, I hope she got the message, so she would definitely look forward to it. So it would be resolved, guys. So don't worry. Please focus now on the thing what we are discussing, and then we would that would be resolved. I'll inform when it is resolved. Okay. So yeah, Ansika, also if you get a confirmation on the same, so just inform me if it is resolved.
Sir,
Yep,
it's working fine from my side.
it's working.
I
Okay,
think
maybe.
he must refresh it or try using
Yeah,
another
yeah, yep,
browser.
yep, yep, yep. So guys, please refresh it once, and you will have no problem on it. So yeah, if we don't have a termination condition, then we'll enter into infinite recursion, and in turn, it will take infinite amount of stack memory. Okay. In the last class, I had discussed internally the background. Actually, the stack is used. Okay, the stack is used internally in the background to maintain the activation record or function call and return address. So if you go on calling function again and again, so that stack is going to increase again, like okay, it will go on increase, right? At a certain point of time, your memory will crash. So that particular condition will be known as stack overflow. You have a beautiful website out there, right, where we get all the answers for our technical queries. So they have taken this name, taken the name from this concept, guys. Stack overflow. You know, when your stack memory will be full, that is known as stack overflow. So if you enter into an infinite recursion, stack overflow will occur. So we don't want to get into that situation. So that's why we need to have a termination condition over here. Okay, and here the termination condition is nothing but we are writing if n is equal to 0, then return from the function. We don't want to proceed further. We cannot proceed further. So n started from 5. Now it has reached a very small value, that is 0, so that we cannot proceed further. This is the termination condition. Otherwise, if n is not 0, we just have to print the value of n. Like when n is 5, print 5. Okay. Then call the function with value n minus 1. Okay. Right. So first time this p function would be called as 5. Then 5 would be printed and the function would be called with value 4. Now this one 4 would be printed and the function would be called with value 3. Now this one 3 would be printed, the function would be again called with value 2. So this would print 2 and the function would be called with value 1, and this would print 1 and call the function with value p of 0. Now n is 0, so we don't have to call anymore. So we just have to return. So first 5 would be printed, then 4 would be printed, then 3 would be printed, then 2 would be printed, then 1 would be printed, and p of 0 will not call any more function, so we just have to return back. So you will get this output 5, 4, 3, 2, 1. This is the recursive code in which you can do in which you can print n natural numbers in reverse order. Okay, this is the code. So as you said, yep, let's actually code it around. We'll code it. Okay, we'll code it here. I would open code blocks and definitely we'll see the output over here for that question. So let me share the same thing with you all. I hope it's clear to everyone what we just discussed. Is it clear to everyone? Yeah, attendance is working fine even for me, guys. It's working. I can see that. Just refresh the page once and it is working. Okay, fine. So, yeah, let me share a screen. I'll be using code blocks, guys, as well. So, doing C++. So, yeah, code blocks is a nice platform. I'll suggest you to work on code blocks if you're doing C++. It's a light and fine platform. So I create a new file. Let me save it as yes. So recursion demo.cp. I'm using C++ here. So hash include. I think I should zoom in a bit. IOStream. IOStream is a class over here. Okay, not header file. IOStream is a class. Earlier it used to be header file iostream.h, but now it's a
Sir,
class. Yep. Say Anshika.
sir,
Yeah.
can
Say
you zoom in a bit?
little more.
Okay,
Okay.
sir.
Now is it
Thank you,
fine?
sir. Yes, sir, it's fine.
Oh, great.
Yes, sir.
So IOStream is a class, guys. Earlier it used to be header file, but now it is a class. So using namespace std. So std is a namespace. It is basically used to organize files or things with the same name. Okay, we want to keep things with same name separate. So that's why. And this cout and cin, those are object of this IOStream class which are present in this std namespace. That's why to use cin and cout, we need to include, we need to specify, okay, we are using this std namespace. Okay, fine. So, oh, my bad. In the main, so here a variable int I. So I'll just write a loop same. Okay, let's go for recursion directly. Okay, so if you're going for recursion here, then it should be n, and we can take input for n. So cout enter value of n. Okay, and then we will take input for n. Then we'll call that function print with the value n by sending argument n. That's all. So return 0. Okay, it's time we define this print function. If you're defining it after main function, then we must declare it before the main function. That I guess everyone knows. Okay, so if we are defining this function after main function, then that function print function should be declared. The prototype should be mentioned before main function. So what is the function? Void print. It takes an argument n. Okay, this is the base condition. Base condition is if n is equal to 0. Then return from the function. We don't want to continue with the recursion. Otherwise, we just have to print the value of n and call the function again with n minus 1. Okay, that is what we are doing here. This is the recursive definition of this function. We have already discussed this. So let's just compile this. So this is compiled. This settings kind of symbol that is actually for build and compile. And yep, there is some error that is I have not put here the double quote here. So let's put that and save it, and then again go for build it. Go for building it. Okay, right, so it's building it. It's taking some time. I'm not sure why it is taking so much of time. It should not take so much of time, but anyway, yeah, no errors, perfectly fine. Now it's time to run. So this is the run button, guys. It would execute your program. So I think I need to also share the output screen with you all. So let me do that. We'll have a look on the output. Yes, I hope you all are seeing the output along with me. Enter the value of n. Let's take 5. Yep, we are getting output 5, 4, 3, 2, 1. Yes, that's working, and we have successfully written a recursive code to print n natural numbers in reverse order. Okay, how to do the, if you just want to print n natural numbers in sequence like 1 2 3 4 5 using recursion. Using iteration, it's fine. We start from 1 and we'll go till n, and every time we print the value of I. But what if we want to print the same thing using recursion, guys? Can anyone give me some idea about it? How to do it? Yeah, tell me. Who will say? I want to print 1 2 3 4 5. 5 is the value of n. It may be 10, it may be 15, it may be anything. Okay, it may be anything. How to print 1 to n sequentially using recursion? How to do it? It's again very simple, guys. What you do is you just take this one, okay, and you put above it, and your task is done. Okay, so now what we are doing, we are first calling the function with n minus 1, then we are printing n. So when you have print of 5, first print of 4 would be called, then you print the value 5. Okay, this print of 4 will call print of 3 and 4 would be printed. I guess you can get it what I'm saying here. Okay, I think you can get it. So it's like this P of 5 is actually calling first P of 4, P of 4, and then it is printing actually value 5. Again, this P of 4 will first call P of 3, then it will print the value of 4. Then this P of 3 is basically calling P of 2 first, then it will print the value of 3. This P of 2 will call the value, the function with value 1 first, then it will print the value of 2. This P of 1 will call the function with value 0, and then it will print 1. Okay, so if you consider this as a root, so we'll come down from here to here. Okay, this calls this will come to here, this calls this will come to here. Okay, will come to here, will come to here. P of 0 we don't have to call anymore. The recursion will stop here because the n value is 0. So it will return. While returning, first it will print 1, then it will print 2, then it will print 3, then 4, then 5. Okay, so this is exactly what would happen there. So let me comment this part obviously because it will lead to error otherwise. So if I compile this code, it will just take some moment, compile it successfully. Yep, there is no error guys, our code is fine syntactically. Now let's execute it and see is there any mistake logically, or we have done the correct logic or not. So I'll share this screen with you, the output basically. Let's see if we are getting the correct result or not. That's the end result right there. That's the end result we want to have. Yep, enter the value of n. So 5. Yes, see, I'm getting 1, 2, 3, 4. 5 is what I'm getting, and this is what I wanted to print. Okay, that's simple. Okay, we don't have to change majority of the code. We just change the sequence of the instruction, right? If you remember this. Okay, we just change the sequence of the instruction, like this and this, we just swapped them, these two things, and yes, we are done with the thing. If you go for iteration, you have to do more changes. As compared to this, you have to do more changes because you then have to write I equal to 5, I less than equal to n, I plus plus. So we have to change a major part of it. So sometimes recursion is good actually. Okay, it's very convenient to write, but sometimes, yep, it would be hard to decode, hard to understand it. So we have to go for iteration. Okay, and sometimes also, yep, if you're using recursion, it will take some more memory. Okay, so is it clear guys? Is it clear? Is it clear? Yes, Hazel, I just I think explained that using that recursion tree thing in the code itself. Like this, you can consider as a recursion tree. This part, okay, this part, like P of 5 on the left, it is a branch. P of 4 on the right, it is a 5. Okay, if you want, I can also quickly show you that. It's not a big deal. I just have to go to this whiteboard and I'll explain the that stuff. Yep. Okay, so there what we are doing is like this P of 5. Let me clear this entire thing. Okay, we just change the statement, we just interchange the order of the statement, and we got P of 5, it called P of 4, and then print the value of 5. Then this P of 4 will call P of 3 and print the value of 4, because first we are calling the function print with n minus 1, then we are printing the value of n. Okay, right? So this would call the function first with value 2, then it will print the value 3, the value of n. Okay, so this would call P of 1, then print the value 2. This will call first the value, the function with value 0, excuse me, and then print the value 1 here. Okay, so now we will go here. Okay, so P of 0, nothing to do. 1 would be printed, 2 would be printed, 3 would be printed, 4 would be printed, and then 5 would be printed and return back, and we are done. So 1, 2, 3, 4, 5 would be the output here. Okay, so I hope that's pretty much clear with you all. Is it correct? Is it fine with everyone? Yes? Yeah? Clear? Okay, that's great. That's great. So, I hope all of you had seen the community yesterday, or maybe in the morning today. So, you might have got an assignment over there. Write a recursive code for GCD. Okay, write recursive code for GCD. I hope you all have done. So when do Das says, can we say header files are same as functions? Not, no, we don't say header files are same as function. In a header file, it is kind of a library. Many functions might be present inside that header file. If you want to use any function present in the header file, you just include that header file. Okay, so yeah, so just work on that GCD thing, guys. So that's again a very good question, but again easy. That particular GCD question is a very simple question, but we still get that question in some of the recruitment drives, like in service-based company like Wipro or maybe Mindtree and all. We still are getting those questions. Okay, we still are getting those questions. Okay, so now it's time we take this concept of recursion and jump into this time complexity. Let's relate this thing there. Okay, what are the different purpose of recursion there? Let's take use of it. So I'm getting to this whiteboard. I'm clearing this off. Please work on the GCD, guys. That's a very good problem. Very easy, but again important. Okay. Till now, some companies are also asking that. Okay, at least in your interviews, someone may ask, or you might have to write that code in the like the coding round. Okay, so better if you are very aware of it. Let me know in the next session if you face any issue in writing the GCD code, or else I would help you out how to do that. So, what we will do now is, first of all, remember guys, I had discussed about, I have told about that 50% discount wala thing. So, I'll share it now. Ansika will share it now. Kindly share the link to them. And you have just 10 minutes. It's 7:30, maybe 31. You just have 10 minutes of time. 7:41, we will stop accepting the responses. So, those who want to be that lucky person, so take the chance of being a lucky person to have 50% discount. Please fill the form. Okay, you'll get a link now in both YouTube, also in the LMS chat. Please fill it up. Yeah, in LMS you might have to copy the thing and paste in the browser. In YouTube you can directly click on it and you'll get to the form and you start filling it up. Okay, you just have 10 minutes of time. Between that you do it, you fill it up. So great. So we have now have a good idea of recursion. What I want to do now is I want to show you an example, another example of recursion, but with that we would discuss something about time complexity in the same problem. Okay, see, time complexity and recursion. These are very important, guys. Time complexity is very, very, very important. I would say, if I have to rate uh, time complexity, I would give a like time a 10 star. From 10, I'll give 10 star in terms of importance. Okay, in terms of importance. So now, what we need to do. I'm here talking about something called Fibonacci, right? We should say Fibonacci. I'm not sure. You can call it anything. Fibonacci, सब नाचने जैसा ही लग रहा है. You can use any term. So yeah, we are talking about Fibonacci series. I hope everyone knows what is Fibonacci series. So it's like zero. See, you might be thinking I'm talking about write a program with Fibonacci series. No, I'm not talking about that. I want to dig something into it. I want to dig into something important in this problem. Okay, so it's something else. Please be there. So 0, 1, 1, 2, 3, 3 plus 2 is 5, 8, 13 and so on, like 21, so on. This is the Fibonacci series that we know, okay? And how we get Fibonacci series? We know that Fibonacci series is nothing but third term is nothing but addition of first two term. Like this 2 is nothing but addition of last two term. 1 plus 1, 2. Then 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. Kind of that. So previous two terms, when we add, the result will give us the next term. That is our Fibonacci series. If you have seen the recursive definition for Fibonacci series to get a term, it looks like this, like int, let's say fib, and it takes n. Okay, so we write here if n is equal to okay 1, let's say, or yep, if n is equal to 0, 1, 0, so that would not do. We have to write both things. N equal to 0, return n equal to 0. Also, actually, we should write here n equal to 0 or n equal to 1. If n is 0 or 1, then we return n. That means if it is 0, it will return 0. If it is 1, it will return 1. That's what. Otherwise, what we have to do is we have to call the fib function. You can write here, okay, let me just clearly write this. It might not be visible properly. Okay, what's happening here? Yeah, there's a lag, a bit of lag. That's what. Okay, now it's good. Let me write it. So if n is 0 or 1, we just have to return the value of n. That is, if it is 0, it will return 0. If it is 1, it will return 1. Okay, but if it is not 0 or 1, what it will return? It will return fib of n minus 1 plus fib of n minus 2. So this is what it will return. This is the recursive definition for Fibonacci series, guys. Okay, so if you are calling Fibonacci of 4, let's say, so what it is doing, 4 is not 0 nor 1, so it will return fib of 3 plus fib of 2. Then fib of 3 will return fib of 2 plus fib of 1. This fib of 2 will call fib of 0 plus fib of 1. This fib of 2 will call fib of 0 plus fib of 1. This is what we'll get. Okay. So if you see here clearly, this one function call is calling actually two functions. Okay, one function is calling two more functions. So we are having two branches. Both the branches are a recursive call of, to the same function. Okay, so again, this is calling two more function. This is calling two more function. This is calling two more function. It is fib of 1, so obviously it will not call any more function. It will directly return 1. Okay, so in worst case scenario, if you see, each level is actually calling two things. Okay, so here we just had 2 to the power 0, one function call. Here we are having 2 to the power 1, two function call. And here in worst case, we might have 2 to the power 2 function call, 4 function call. Are you getting my point, everyone? What I'm saying here? Are you getting my point? What I'm saying here? Please respond here in the comment. So each function is actually calling two more functions. So at every level, actually, you can say at every level we are getting two more function call. Okay, not getting this. Okay, I think I have to go in a different direction for this one. Okay, Piyush says yes. Vajanti Pandey says yes. It's looked like a chain system, yeah, kind of that, Komal, you can say. So this is what happens in Fibonacci recursive logic. Okay, so one thing is calling two function more call. So you have see fib of 4 called fib of 3 and fib of 2. Fib of 3 called fib of 2 and fib of 1. Fib of 2 again is calling fib of 0, fib of 1, and fib of 0 is being called again by fib of 2. The fib of 0 and fib of 1 are being called by fib of 2. So each function call is calling two more functions. So at every point, every node, we are having the same thing. We are getting the same thing here. So each one is calling two more function call, two more function call. So it is actually becoming kind of this way, right? This we had one function call first. It gave us two more function call, and each of this function call gave us each two function call each. Okay, so this is kind. It is growing in this way. Okay, it is growing in this way, two in every level. So we had only one function call, that is 2 to the power 0. Okay, in next level we are actually having two function call, which is 2 to the power 1. In the next level we are having 2 to the power 2, four function call, and this level we are having 8 function call, that is exactly 2 to the power 3. So likewise you can think of 2 to the power n levels. So there are total 2 to the power n function calls. There would be, in worst case, there would be 2 to the power n function call. Yes, it is exponential, Subhendu. Yes, exactly. That is what I'm trying to say here. It is kind of exponential. The function call grows exponential. Time complexity is going exponential, 2 to the power n. So obviously here, this recursive logic is not a good solution. Okay, 2 to the power n time complexity is so much. It's very large. Most of the companies, product-based company or service-based company, wherever you go, mostly is product-based company, which are into this. When you are going for competitive coding, they would expect you to solve in linear time complexity majorly. Linear maybe n square is fine, but 2 to the power n never they will allow for 2 to the power n most of the time. 2 to the power is a very large time, 2 to the power n. Okay, n log n n square they might allow you for n square, but 2 to the power is something very large, so they will not allow. So you have to come with a different logic for this one. This surely fails here, this Fibonacci series. That is where, okay, so this is actually solved by some other technique. Okay, see, one more thing what we are doing. If you clearly see here, this fib of 2, okay, this fib of 2, you're calling here, again you are calling here, same function is called twice. Okay, so this fib of 1, fib of 1 is called here, called here, called here. Fib of 0 is called here and called here. So if you see here, what is recursion, guys? What we are doing here, we had a large problem here and we divided it into small part. Okay, we call it as sub problems, or optimal sub problems, we can call it as. We had one problem, we divided into sub problems, small part. Okay, we would get result of small problem, finally we'll merge them together and find the final solution, right? And here the sub problems are repeating. Actually the sub problems are repeating here. Okay, this fib of 2 is getting called many times, fib of 1 is getting called many times. I have just taken started from n4. If you start n from 7 or 8, we'll see there will be many repetition of the same function call at many places. Okay, so we say that, okay, repeat, the sub problems are getting repeated. Okay, yeah, guys, please, Anshika has also pinned it here. So it's last minute. You have last minute to fill that form in order to have 50% discount. Anshika, please also put that link again in the chat, just 2 or 3 times, so that they can have it there and fill it up. I'll just close the response within 1 minute. Please do it, guys. Okay, so here the sub problems are repeated. That's where actually this problem, if you want to solve it in very less time already, maybe order of n. Okay, so here comes into picture dynamic programming. We solve this question using dynamic programming, guys. Fibonacci. Okay, the optimized solution of Fibonacci series question is dynamic programming. You might be thinking, what is dynamic programming? Why are you talking about dynamic programming in the very second class when we are just talking about time complexity? So let me tell you, guys, dynamic programming solution of Fibonacci series is something you already know it. Okay, dynamic programming solution of Fibonacci series is nothing but the iterative solution of it. Okay, that we just discussed. It's nothing much a big deal. So it's like, okay, you have this function. Okay, so it's like we have a equal to 0. Okay, b equal to 1, first two numbers of Fibonacci series. Okay, so we'll find this third value. Third value is nothing but a plus b, so we print the third value now. Already we will print a 0 and b 1, so 0 and 1 would be printed. Now we are calculating the third value by doing addition of a and b, previous two number, so we are printing the c value. Got it? Now we need to make this one as the first value, this one as the third value, the second value, sorry. So third will become second, second will become first, because we need to find the next number. So what we need to do here, tell me. So first number will become the second number will become first, and third number will become second, so that when we loop around here, this a plus b would be again calculated. So 1 plus 1 plus 1 would be 2, so that would be the next third number. Then next time 1 would be first number, 2 would be second number, so we'll do 2 plus 1, that is 3. Okay, that is how we will go for it. And yeah, this is a loop basically we'll do here. That is how we would do this. Okay, here I can write here like I less than equal to n. Okay, you can start from I equal to 2, because we have already printed 0 term and 1 term, so you can start from I equal to 2 and you just increment I. This is your while loop, guys. Okay, n minus 2 times it will run, it will print the rest of the numbers. So this thing, if you see, this is just taking big of n time complexity, because this is running for n times, the loop is running for n times. I'll give you some more example where you will understand how to actually calculate time complexity. I'll give you some more example here. So that is what we are doing here. This loop is exactly running for, you can say, okay, this loop is running for n minus 2 time, but in time complexity analysis, we don't take into this constant terms into account. So you can ignore this 2 and say, yes, this loop is running n times, so the time complexity would be big of n. Okay, see, where was 2 to the power n, where is big of n, like n linear time, 2 to the power n exponential time. So much difference with a simple technique, that is dynamic programming. Okay, dynamic programming is nothing, guys. What we are doing is we are storing the current result so that we can use it later. Yep, I just forgot one thing. I'm closing that form now. Okay, it's already time, so I'm closing that form. Those who have submitted it, those who have filled it, that is fine. But now I'm going to close it now. Again, we'll have this form next day. Okay. Yep. Yeah. So I have stopped it. Now you cannot fill that form. Now let's. Yeah, I was talking about this time complexity. Okay. I'll give you some example where we would understand in a better manner how exactly to find the time complexity, how to calculate the time complexity. Okay, real time example of Fibonacci series. Let's talk about a game, right? Let's talk about a game. I don't want to get into that right now because it will take so much of time, Prathamesh. Uh, Pratham is not exactly a scholarship exam for full stack course, but I have rolled out this link for the form. Every day, who would be filling this form, I would on the last day, I'll just run a Python script over it. Randomly, I pick a person, and that would be the lucky winner, would be getting 50% discount for the full stack course. That's what I have planned it for you all. Yep. So let's talk about time complexity. Okay, so if I take a very simple example where let's say I is equal to 1 and the condition is I less than equal to n, and here I'll do something, let's say see out high. Okay, and this I plus plus, I is incrementing one by one. Okay, so how many times this loop is running? We know that this loop is running n times because I is starting from 1, and the loop will run till I is less than equal to n, and every time I is getting incremented one by one. First I is 1, then 2, then 3, then 4. So this basically is running for n times. So this is big of n time complexity. Okay, we normally denote with big of big O with big O because we are concerned about worst case time complexity, guys. Okay, worst case time complexity. We don't go for average or best case time complexity. Normally, whenever time complexity comes into picture, we say yes. At worst case, what is the time taken by the algorithm or taken by the function or taken by the logic? Okay, because we want to be prepared for the worst case, or if you want to compare two algorithm, obviously we should compare at the worst case. We cannot take a best case scenario and say, okay, this is working better, this is not working better. That we cannot say. At worst case, we should compare both one and let's see which one is performing in a better way. Okay, that's how we do it. So this is big O of n time complexity. The same thing we can also do here. If you write a for loop for I equal to 1, I less than equal to n, okay, I plus plus, and if you print here this value of I, so this is the same thing. The loop is running for n times. You print I, hi, anything, but the loop is running for n times, so this is also big O of n. Okay, there are many asymptotic notation. This big O is asymptotic notation. One is this big omega, one is this big O, and one is we have theta. Okay, this is used for best case. This big O is used for worst case, and theta is used for average case. But remember, when we are comparing two algorithm, which one is best, which one is not, we always go for worst case scenario. Like we discussed about the Fibonacci problem, if you go for recursion way, that is taking 2 to the power n time complexity. Okay, so we are coming down to dynamic programming way, that is nothing but the iterative solution, which is taking big of n at worst case. Okay. Understood. So we are mostly concerned about worst case scenario. We need to see that at worst case, which one is performing better. Yep, you'll get certificate. But the thing is, you have to give attendance regularly, guys. You have to give attendance regularly. That's where you can get certification. Okay. No fee for this course, Rohit. Absolutely no fee for this course. This is free of cost. Okay, you learn it, apply it. But yes, if it's just a few drops from the big ocean of data science algorithm. So if you want to have complete knowledge of data science algorithm with other placement related stuffs, you can have a look on our full stack courses. We are also providing some discounts, guys, already. You can have a look on that. And again, I've shared the link for having 50% discount. You can also there fill out there so that you can be that lucky person. Okay, so yes, let me clear it out and I'll discuss one more problem. Okay, it was a simple for loop which is running n times, so linear time complexity. But let's talk about this thing for I equal to 1, I less than equal to n, I plus plus, and inside it I have one more loop for j equal to 1, j less than equal to n, j plus plus, and I will print here, let's say hi, or maybe hi, let's upgrade whatever, something. Okay, whatever I want to print, I'll print here. The question is, what is the time complexity this one? So you can see on the top of it. Okay, you can see the on the top of it, you'll say, okay, this is big O of n, you'll say, or maybe I should not write big O of n. Anshika, like as far up to this point, is everything clear to everyone, including you, or you have any doubt, or any one of them have any doubt? Yep,
No,
Anshika.
sir, it's pretty much clear for me till now.
Okay.
And others, they were asking for that real time examples which you have already given. So it's cool.
Okay, fine, fine. It's fine. Tanya, you can still fill the attendance form. Yeah, that's what I needed to say you. Even if you are watching the recorded session after the live session, you can still form the attendance link. But it is always better to attend live because you can ask questions and I can clear it out. If you watch it later, your question might not. Okay, there will be no one to what is that? Entertain your doubts, right? Okay. And again, you are missing out the chance of having 50% discount also for the from the full stack. Yep. Okay. So this is the loop. So you might say that okay, this outer loop is running for n times because I starts from one and it goes till n. Inner loop also runs for n times. So in total, it is n into n. You'll say it is okay. Big of n square is the time complexity. Yeah, you are correct. I'm not saying that you are wrong, but I would suggest you don't look at this in this manner. I want to change your perspective. Okay, don't solve this question in this manner. Why? Because if they change something here or here, then you will be in trouble to find out the time probability. See this trick or see this method where how I am finding out the time probability for this one. You write the value of I and j. Okay, I and j started. What are the values here? I is starting from 1. Let's say first value of I. In the first iteration, I value is 1. For I equal to 1, what is the possible values of j? J is running for 1 to n. Yep, j is running from 1, 2, 3, so on up to n. How many times that is exactly? N times. N times j loop is running. Inner loop is running n times for I equal to 1. That means high would be printed n times. Next iteration when I is 2, j possible values of j same thing 1, 2, 3, so on up to n, again n times. Okay, next iteration when I value is 3, same thing. Okay, n times the inner loop will run for and high would be printed n times. If you see here in each iteration high is getting printed n times, and the number of times this statement is executed, that would give me the time complexity. Okay, that will give me my time complexity. Okay, got it? That is my time complexity. Assignment is not compulsory, Priya. Okay, it's just for your practice. If you want to submit, you can submit. There's no deadline for that assignment. Okay, so likewise, when I value would reach n, j would take up value, same value like 1 to n. It is also running n times. Okay, so how many times in total this C out high was executed or high was printed? It's nothing but if you add all this up, so n times plus n times plus n times, so on. The last is also n time. How many n's, guys? How many n's you are adding? How many n's? Subhendu, you didn't get the last point. Okay, I would no fee. Priyanshi, no fee. See, when I is 1, when I is 1, J loop is running for n times, 1 to n. So basically, high would be printed n times. When I is 2, J, same thing, J would run for n times, so high would be printed n times. Similarly, at some point of time I would reach n. So when I value is n, j would run for same n times and your high would be printed n times. So total how many times high printed? In first iteration high printed n times. In second iteration high was printed n times. In third iteration high was printed n times. So n times n times n times. When I value is n, in at the nth iteration high is again printed for n times. So total number of times this high was printed is nothing but you just have to add this all up. Okay, n plus n plus n plus n. So total you will see these are nothing but n number of n's you are adding. Okay, so n times you are adding n, that is nothing but n into n, total n square. Time complexity is nothing but n square. Okay, n square. So time complexity is n square. I want you all to look this thing in this perspective, guys. Okay, this is the way through which you should actually find out the time complexity, because they might change something here or here. Then you would if you just think in this way, then you might make mistake. Always go for this way, guys. Take I value, j value, see how many times for I value 1, how many times is j loop is running. Okay, what is the next value of I? How is I is running? I value is next value of I is 1 or 2 or 3 or 4. That's what you need to take care of. Okay, right? So that is how you find out time complexity for this kind of question. And yes, I remember the question. like how to exactly find time complexity. So this is the process, guys, in which you need to find the time complexity. This is how you analyze time complexity. Okay, there might be like, see, this might be a loop for I equal to 1, I less than equal to n, I plus plus, and here it might be for j equal to 1, j less than equal to n, j equal to j into 2. See, now they are changing stuffs. Okay, they're changing the stuffs. So what you have to do, when I is 1, j is actually running for how many times? It's every time it is multiplied by 2. When, so j value, first time it would be 1, then it would be 2, then it would be 4, then it would be 8, then it would be 16, so on. Okay, if you take any value of n, let's say 64, let's say n value is 64, 16, then 32, excuse me, then 64. Okay, see, we have reached the value of n. This is the last time this loop would run. How many times loop run? One time, two. Okay, in first step we reach from 1 to 2, in second step 2 to 4 we reach, and for third step we reach from 4 to 8, in fourth step we reach to 16, in fifth step we reach to 32, in sixth steps we reach 64. So basically the loop is running for only 6 times here. Okay, the loop is running for only 6 times. 64 6 times. Okay, what is the relation? Log of 64 is 6. Okay, log of 64 is 6 base 2, obviously. So I can say that this j loop is actually running for log n times. Okay, for each value of I, this j loop is running for log n times. Okay, with every time it is getting incremented by 2 2. When I say log n in computer science, guys, automatically the base is 2, not like mathematics. In mathematics by default base is 10, but in computer science when I say log n, automatically by default it is base 2. Okay, so for I equal to 2, same j would run for log 2 base n, same time. So when I is n,
Sir,
j loop will run for log n base 2. Yep, Anshika. Yeah,
sir, I
say.
was saying that time is up, so I would like you to bind it up.
Yep, it's the last thing which we are doing.
If you
So
feel fine. Yeah. Okay.
yeah, it's the last thing we are doing. We'll do it. Okay, so see guys here what we are doing. So every time now j loop is running for log n time. If j loop is running for log n time each time, then whatever statement inside it, let's say hi or hello, whatever. So that would also get printed for log n times every time. So log n, log n, log n. So what is the total number of times this high will be printed? You just have to add this on log n plus log n plus log n plus log n plus log n. How many times? N times, because I is running for n times. So n into log n would be the time complexity in this case. I hope this is clear, all of you. What do you say? Is it clear, guys? Nayan, you don't have to have a link exactly. You can just put that in the LMS. Right beside the chat tab, there is attendance tab. So you can just click on any emojis as you feel, however you want to rate this session. Just select it, put some, if you want to suggest, give some suggestion, write it down and you can just save. Okay. Okay. We had one assignment for the previous class. I had asked to write a recursive logic for GCD. Okay, greatest common divisor or HCF, highest common factor. We had done that. Okay. Okay, Shubhendu, what I'll do is we are already up on the time. I'll do that question again in the next class. What's it? Okay. So we'll do that question again. I'll explain that logarithmic wala question again in the next class. So don't worry about it. I'll not left you puzzled. So we'll do that again in the next class. So this is what for this session. Okay. Let's meet in the next class, guys. Bye bye and take care. Yep, Anshika, you can wind it up.
Thank you so much, sir. It was really amazing, and I hope you all guys have enjoyed it. So keep learning, keep hustling, and don't forget to join in again tomorrow at the same time. Happy learning. Bye bye.